Here we'll be discussing about Azure Containers. So Azure Containers are virtual environment. So much like running multiple virtual machines on a single physical host, you can run multiple containers on a single physical or virtual host. So unlike the virtual machines, you don't manage the operating system for a container. So the virtual machines appear to be an instance of an operating system that you can connect and manage. So containers are lightweight and designed to be created, scaled out, and topped dynamically. So it's possible to create and deploy a virtual machine as application demand increases, but containers are lightweight, more agile method. So containers are designed to allow you to respond changes on demand. With containers, you can quickly restart if there's a crash or hardware interruption. One of the most popular container engines is Docker, and Azure supports Docker. Okay, let us see a small video on this Azure container.
In this video, we'll discuss the difference between virtual machines and containers. So let's begin. Deploying server applications has always been complicated. That complexity drove system admins to start looking at virtualization techniques like virtual machines and containers. Virtual machines, or VMs, provide an abstraction layer for CPU, memory, and storage. They can be changed without having to invest in new hardware while still allowing the environment to be flexible and secure. With VMs, you're in control. You decide the operating system, install tools and packages, and your app runs either in isolation or with the other apps you install into the VM. But there are downsides. VMs can only run one operating system at a time. So if you have multiple server apps that all require different runtime environments, they may also require multiple virtual machines to execute properly. And because the VM is emulating a full computer, tasks like starting one up or taking a snapshot are pretty slow, often taking several minutes. But there's a lighter weight solution that solves some of these issues: containers. A container bundles a single app and its dependencies, referred to as containerizing the app, then deploys it as a unit to a container host. The container host provides a standardized runtime environment which abstracts away the operating system and infrastructure requirements, allowing the containerized application to run side by side with other containerized apps. An easy way to differentiate between VMs and containers is virtual machines virtualize the hardware, while containers virtualize the operating system. The operating system level virtualization of containers is one reason why the container approach is more efficient than a full virtual machine. It allows you to run multiple lightweight containers on a single host without sacrificing the isolation that the virtual machine originally offered. Azure supports several container variations, the most popular being Docker. Unlike VMs, you can spin up containers quickly. You're just waiting for the app to launch instead of both the operating system and the app. Also, containerized apps tend to be much smaller in size, and the development process is simplified because your development runtime environment can look exactly like the production environment. Another advantage to containers is that they can be orchestrated with container cluster orchestration. You can easily deploy and manage multiple containerized applications without worrying about which server will host each container. The decision of whether to use a VM or container depends on how much flexibility you need. If you need to completely control the environment, then you might choose a VM. If not, then the portability, performance characteristics, and management capabilities of containers might be the better choice.
So Azure Container Instances. Azure Container Instances offer the fastest and simplest way to run a container on Azure. So without having to manage any virtual machine or adapt any additional services. So Azure Container Instances are a platform as a service, as a PaaS offering. So Azure Container Instances allow you to upload your containers and then service runs the containers for you. So Azure next is Azure Container Apps. So Azure Container Apps are similar in many ways to a container instance. They allow you to get up and run right away. They move the container management piece and they are PaaS offering. Container apps have extra benefits such as ability to incorporate load balancing and scaling. These other functions allow you to be more elastic in your design. So Azure next service will be the Azure Kubernetes service. So Azure Kubernetes service in short AKS is a container orchestration service. So an orchestration service manages the life cycle of containers. When you are deploying a fleet of containers, AKS can make the fleet management simpler and more efficient. So use containers in solutions. Like what solutions we can use the containers. So you might split a website into container hosting your front end, another hosting your back end, and the third for your storage. So this split allows you to separate portions of your app into logical sections that can be maintained, scaled, or updated independently. So imagine your website backend reaches capacity, but the front end and the storage aren't stressed. So with containers, you could scale up the backend separately to improve performance. If something necessitated such a change, you could also choose to change the storage service or modify the front end without impacting any of the other components. So say this is an important difference between a VM, using a VM and using the containers. So you can have this logical split of your applications running, so that you can scale up or scale down only the particular portion which is having high traffic or low traffic. So in short, the containers are very lightweight, portable, and self-sufficient way to run the applications. When we are talking about VMs, so VMs are like workloads on virtualized hardware. So your VMs are stronger isolation since the VM has its own operating system, but the other way, the containers share the host OS. So this makes the VM more secure but heavier in terms of resource usage, because it doesn't share the host. Like it has an individual, or it has a separate operating system hardwares and separate as an isolated atmosphere. So it makes it heavy and more resource usaging thing. Then in case of resource efficiency, containers are more lightweight and efficient in terms of resource usage compared to VMs, as explained in the previous point. Then for portability part, right, containers are more portable and can be easily moved between the environments, while VMs are more tied to the underlying infrastructure. Moving a VM is not that easy as and simple as the moving the containers. Then for scaling part, containers can be scaled more quickly and efficiently than VMs, especially the context of microservices architecture. So the one which we explained here. So because you are going to just scale up the microservices architecture, only the portion of the application which needs more resources only. So you're not going to scale up the entire whole machine. So that makes it very easier and simpler for scaling up. So these are the comparisons between Azure VM and Azure Containers, and also it just depends on the situations, and it just depends on our requirement. Okay, we see the creation of container here. So this is my account with free subscription. So when you have an Azure account, you can have a free 1 year free subscription with the $200 USD of equivalent credit. You can use that to do your practices. Just make sure any resources you create, you shut down them before your closing, so that you are not charged for it to running backend. So you can search for the Azure containers here, then click on create. So resource group, I just create a resource group. G1. Then container name, Techify with Adil. Sorry, Techify with Adil. Container 1. Okay, then availability zone. So okay, just we leave it as standard and SKU as a standard one. So here you can for image you just leave it as quick start image. There's a default one, or you can just choose. So this is so here I'm using other registry, meaning under the Docker. So here you can see I have added Nginx. This is actually a web server. So in my previous video for Azure virtual machine creation, under the video we would have done the same creation of web server, but for that we would have created the base as virtual machine. So we have to first create a virtual machine, then do the all connections for the virtual machine. Once that's all done, then we install the web server on it to run. So in this container exercise, we no need to do all those setup. We just use the image, and we are just going to make it up and run. So this is a very basic differences how the container is more helpful, but the thing is it's just based on your requirement. So in general your Azure virtual machine is going to be heavy, like it has more control over the OS and the structures and everything, which the container doesn't have. So it just depends on our requirement. So we have validated everything and we are just ready to go. So once you click on the create, so it is going to create your Azure container for NGX web server setup. So this is going to be more easier and more easy to set up and also to create when compared to your virtual machine, because it's going to be a platform as a service thing. So your infra, everything is managed by your Microsoft here. So it's going to be very easy for the creation purposes. That's why it's called as a lightweight Azure instance.